Hello, am I audible, everyone?
Yes, sir.
All right, we're going to start the class in a few minutes. Good evening. Shabya, you are not there in the last class, right?
Yes, sir.
Okay, have you watched the lectures?
Sir, I asked Nishkar sir to send the recordings. Sir told sir will
Mhm.
send.
All right, all right. All right. Let's start the class with a question. How many three-digit numbers more than 600 can be formed by using the digits 2, 3, 4, 6, and 7? All right, try to solve this. And students who were not there in the last class, don't worry, I'll explain, all right, after a few minutes.
Okay, sir.
Yeah. Remember one thing, in this chapter, we don't leave our common sense out of the room. We take it and use it as much as we can. All right. Common sense is the first thing that we use in this chapter. All right. And the method we use in this question is called box method. Right. The methods are just to remember, right? Nothing too technical here. See, we need a number more than 600. Everyone, we need a number more than 600. And that number should be three-digit number. That means 600 to 1000. So we make three boxes, 1, 2, and 3. All right, because we want three-digit numbers. The condition is it should be more than 600. So if I fill in 2 here, so any number I fill here, this whole number cannot be more than 600 because it starts with 2, right, Shravya? Am I audible, guys?
Yes, sir.
All right. So I cannot fill this with 2, 3, or 4, right? Because then the number would be less than 600. So what can I fill it with? Only 6 and 7. So two options to fill this box. Now here I can fill any number and that would be more than 600. So I have total of 5 digits. So I can fill 5 digits here, also 5 digits here. So 2 into 5, 10, 10 into 5, 50. This is the answer. Two options to fill the first box, 5 options to fill the second box, 5 options to fill the third box. Is it clear? Gautam? Who are new? Arsanan also, you were not there in the last class. Ashma, I guess, was there. Abdul was there. Is it clear, everyone? All right. Let's do another question. You have a multiple correct question. Write down. All right. If you want to note it down, just note it down. Then we'll do a question. All right. In how many ways a student can answer a multiple correct question with 4 options? All right. There is a single question and that is multiple correct. Multiple correct means A, B, C, D. There are 4 options and it is not single correct. A, B, C, D all can be correct also. You must have seen question like this. Please try to solve this. Anyone solve this? Gautam, Ashma, Harshal, Abdul, Shavya. Students, if you don't speak or say anything, I will not be knowing where the problem is, right? So if you want just that I teach and go, then we can do that also. But it would be far more better for you if you speak, right? Yes, Shavya. See, in the questions, MCQ questions, solve this one first. If you have a question with four options, A, B, C, D, not single correct. That means there is a question and you have to tick one. In how many ways can you answer this? Four ways, absolutely right. You can either tick this one or this one or this one or this one. So total of four ways. And this is called fundamental principle of addition, right? Whenever you see as this or this or this or this, then we add things, all right? This is one way to do, one way to do, one way to do, one way to do. We are using or, so I added them and four is the answer, right? But when the options become multiple correct, right? That means the answer can be ABCD or AB, ABC, BCD, like that. Have you ever solved this type of question where there can be multiple correct options, right? So how to solve? C. Look at option 1, option A. This can either be true or false, right? This can either be correct or not correct. So two options. Same for B. This can either be true or not. Same for C. Same for D. So two ways to do this. Two ways to do this. Two ways to write. You are either going to tick or not going to tick, right? So again, I'm using or this or this. That is why two ways, two ways, two ways, two ways. But to answer a question, you have to tick or not tick and do this and do this and do this. So we are going to multiply these options. So the total answer is 16 ways. Is it clear? You can either tick A or not. You can either tick B or not. You can either tick C or not, and so on. Everyone, is it clear? Give me a minute. All right. So 16 ways to solve this. But the question says, in how many ways can you answer this? All right. But in this question, there is an option where you left all the options blank. So we have to subtract that. So the answer is 16 minus 1, that is 15 ways, right? Because you have to tick at least one of them. You cannot leave all of them blank. Is it clear? Okay. Next question. Okay, why 16 minus 1? All right, see. As soon as you saw the question says, in how many ways can a student answer this, right? So to answer a question, you have to tick at least one of the options, right? You cannot leave the question. And when I solved this, I said you can either tick A or not A. You can either tick B or not. You can either tick C or not, like that. And I calculated the answer was 16. So there is also an option where I didn't tick of them. So I have to subtract that option. All right. That is why I subtracted one from that, where I left all the options blank because
Yes.
I have to answer. Yeah. Another question of the same format. Think about this question. All right. In how many ways did you get the fundamental principle of multiplication and addition? Whenever you have to use and, you have to do this and this and this and this. You have to multiply. When you have to use or, you need to add. In how many ways can a student answer 10 questions? All right. This is a two-part question. If the questions are single correct, if the questions are multiple correct. All right. Try to solve this, then we'll discuss. And don't get demotivated when you cannot solve questions in this chapter. All right. We are just trying to learn. There can be 10,000 different questions in this chapter, but we have to just build the understanding how to solve, right? There is no single way to solve questions. As soon as you get the understanding or the common sense how to solve, every question is easy. All right. So focus on how to build the fundamentals. You have 10 questions. Option 1 says if the questions are singly correct, how many ways to solve? Second part is multiple correct, and how many ways can you solve? Okay, Stabhya, can you tell me how you solve this first part? Yes, single correct. So in the first question, you have four options. How many ways can you solve one question? Right. But see, there is a difference, right? I'm not asking in how many correct ways, right? If I have to ask in how many correct ways, I'm just asking in how many ways a student can answer. You can be wrong also. So in how many ways can you answer first question? Four, right? You can either be wrong or right, but there are four options. Now four options to solve first question. Again four ways to solve second question, and so on for 10 questions.
Yes, sir.
Yeah. Now do I have to add them or multiply them? That is the question. Add them. Why add them? Yeah. Look at the words. All right. When you speak, you have to solve this question, first question, or second question, or third question, or fourth question. Is it so? Yes, definitely. You need to think like previous question, but look at the words also, right? You have to solve first question and the second question and the third question and the fourth question, right? Whenever you use the word and, you need to multiply, right? ये भी solve करना है, ये भी solve करना है, ये भी solve करना है, ये भी solve करना है. You need to multiply. Four options for this, and four options for this, and four options for this, and four options for this, like this 10 times. That means the answer is 4 raised to the power 10. All right. Is it clear, Shavya?
Yes, sir.
Okay. Now try the second part. Yes, yes, definitely, Shavya. I know that. I'm just going with the flow, right? Why waste these 2 hours also? In the previous classes, I just told about factorials. We are not using factorials as of now. All right. These two things you needed to know: fundamental principle of addition and multiplication.
So could you summarize that?
Yes, see, I'll explain briefly. Fundamental principle of addition is, we all know this since childhood, right? If I ask you, there is a room, all right, and four exit gates, and you are locked in this room. In how many ways can you go out?
All the four ways, like any four ways.
Any, and the answer is four, right? You
Yes,
can
sir.
go. So how do you know the answer is four? If you can explain me how you got to know the answer is four, then the concept is clear. See, your mind already knows the answer, four, right? And this chapter is all about that only, getting the answer. See, as soon as you saw four doors, your mind says, I can go out of this or this or this or this, right? One way is this, one way is this, one way is this, on one way is this. Absolutely right. That person can move through any four ways, right? And any four means there are options. You can do either this or this or this or this. There is no compulsion to do all of them. And when you use options, that means either this, you add the options, you add the number of ways. All right. So one way was this, one way was this, one way was this, another is this. You add all of them. So answer is 4. We could have multiplied also 1 into 1 into 1, but that was wrong. Our mind already knows that. That is why this is called fundamental principle. Yes, or means addition. All right. Now, suppose you are standing outside a room and there are 2 entry gates. This can only be used for entry at 4 exit gates. All right. In how many ways can you enter and exit out of this room? You have to reach a point B, let's call it joining end A and B. You have to reach till B. In how many ways can you do this? Can you answer, Shabya? Right? You can enter in any 2 ways. Right? Exit in 4 ways. But 6. Okay. Why 6? Why did you add them? See, yeah, the question is why. See, to fulfill the goal, what was the goal? You have to reach from A to B, right? So if you speak in English, how are you going to say? You have to enter or exit, or you will say you have to enter and exit, which is the statement. You have to enter or exit, or you
Enter
have to
and
enter
exit.
and exit, right? Both the things are compulsory. You have to enter and you must exit also. Then only the goal is completed, right? There are no options.
Yes.
So 2 ways to enter, 4 ways to exit, and you have to do both of them. So you need to multiply 2 into 4, 8, right?
Yes, sir.
Is it clear?
Yes, sir.
Okay. This is fundamental law of multiplication, a fundamental principle of multiplication.
Okay, sir.
Yeah. So now come to the previous question. Please solve the second part. All right. Break it into parts. How many ways to solve first question? Then how many ways to solve 10 questions? You will get the answer. See, not 16. We solved that. The answer was 15, right? You cannot leave any options. Yeah, first question is 15 ways. Now for 10 questions. Absolutely right. So first question to be solved in 15 ways, then 15 ways, 15 ways. You have to solve this and this and this and this. So you need to multiply. Clear, Shabya?
Yes, sir. Sir, if the question was odd, then we should have added, right?
Yes, yes. See,
Okay, sir.
say it like this. In the single correct options, we added them, right? You either tick this or this or this or this. So we
Yes,
added them. Okay.
yes, sir.
All right. Another question. How many 4-digit numbers can be formed using the digits 1, 2, 3, 4, 5? If the repetition of digits is not allowed, repetition of digits is allowed. All right. Solve this in the box method. You need 4-digit numbers. That means 4 boxes. All right. You can fill in how many ways? Try to solve this. All right. And what happened to rest of them? Abdul, Arsalan, Ashma, Gautam, silent as the sea. And yes, in the next class, there is a viva of conic sections. All right.
Okay, sir.
Yeah. Try to solve this. Abdul, Ashma, Arsalan, Gautam, are you able to understand this chapter or not?
Yes, sir.
Listen, why are you not speaking anything? It's been like 45 minutes. See, again, silent. Gautam, you are never this shy. Okay, Ashma. Even Ashma used to speak. But are you guys feeling cold? Gautam, where are you from?
Sir, Kerala, sir.
Kerala. What is the temperature there now?
It is hot, sir.
Hmm?
It is hot.
Hot, all right. Okay, Ashma has disturbances in mic. Abdul, where are you from? Hyderabad. Is it cold or hot there? No idea? All right. See, in online education, you cannot. Okay, you are in the Saudi Arabia. All right, all right. In online education, students very, untrustworthy. I believe you guys might be just sitting inside the kambals and watching the lectures. Okay, Gautam, solve this question.
Yes, sir.
All right, send me the answer. Okay, Shavya, what about you? Solve this.
Solving, sir.
Solving. All right. Yes, let's look at the answer. We need 4-digit numbers. So 4 boxes, right? The first box can be filled in 5 ways. This is the first part, right? Repetition of digits is not allowed. So first box can be filled in 5 ways, second box in 4 ways, third in 3 ways, then 2 ways. You can find the answer. Gautam, how did you have 125?
Sir, 120 leg out. And by mistake type 125.
Okay, okay. And the second part?
Sir, 625.
625. All right. Shavya, please try to answer the second part also.
1 minute, sir.
All right. right? So first box can be filled in 5 ways, and because the digits can be repeated, this can also be filled in 5 ways, 5 ways, 5 ways, and we have to fill all of them. We have to fill this and this and this and this. So 5 raised to the power 4, that is 625. So I hope everyone is clear about that. Next question. How many 3-digit odd numbers can be formed by using the digits 1, 2, 3, 4, 5, 6 if repetition is not allowed? Repetition is allowed. Okay, focus on 3-digit odd numbers, right? So try to solve that. Gautam, have you solved this?
Yes, sir.
Okay, send me the answers. Now, Ashma, Abdul, Shravya, look again. You need 3-digit numbers out of these numbers, right? And they should be odd. Gautam, how did you have 6 as the answer? Gautam, can you explain?
Yeah,
Right,
five,
right.
three,
Three
two.
options here.
Yes,
And this, in how many ways can you fill the first box?
sir. Two,
Why 2?
sir, because repetition is not allowed.
Absolutely right. But see, for a number to be odd, only the units place it, right? 2 to 1. This is also an odd number.
Yes, sir.
Right? 2, 4, 1. Odd number. So this last box can be filled by 3 numbers. Right? Only 1, 3 or 5. But this can be filled by any number. So when one number is filled, that means 5 remains here and 4 here. Is it clear?
Yes, sir.
Okay. Shavya, what about you?
Yes, sir.
Okay. So answer is 60. Now try the second part. Shavya, how is the answer 125? First box. See, let's start with third box, right? Because odd numbers is the priority. So 3 ways to fill this box. Now first box. Five. But total we have 6 numbers, right? And repetition is allowed in the second part. So here 6 ways to fill. In the second box also 6 ways. So this is 108. Clear? Gautam, Ashma, Arsalan, Abdul.
Yes, sir.
Okay. Let's try another question. See, all this chapter is questions only, right? Not much theory about this. There are 10 lamps in a hall. Each one of them can be switched on independently. The number of ways in which the hall can be illuminated. Alright, try to solve this. There are 10 lamps in a hall. Each of them can be switched on independently. In how many ways can you illuminate the room?
Sir, it is the number of ways in which the
Room can be illuminated. And the hall can be illuminated. And this is the hall.
Sir, each of them can be.
Switched on independently.
Okay, sir.
Yes, Rabia. Look at this question as the question we did of multiple correct questions, right? There are 10 bulbs. They are simply asking in how many ways can you illuminate. That means you can either switch on B1 and B2, B1, B2, B3, B2, B3, B4, like that. All right. In how many ways can you do that? So see, you look at the switch of B1. You think you can either switch it on or off. So two options. Same for B2. Same for B3. Right?
Yes, sir.
So what will be the answer?
2 raised to 10.
2 raised to the power 10. But again, the room has to be illuminated. And the options we
Minus
counted,
1.
-1, absolutely right. So this is the answer. Gautam, Ashma, Abdul, clear?
Sir, why -1?
Right, because the options we counted, there is the option of all the switches being off, right? There is an option where all the switches are off also, but the room has to be illuminated. So we have to take the option out. Is it clear, Gautam?
Yes, sir.
Okay. You are absolutely clear, right? Because in the future, this is going to be very troublesome. If you are not clear about anything, ask. I told you before also, this chapter is all about fundamentals. Once that is clear, no question is difficult. But if that is not clear, every question is going to be the most difficult question of your life. No matter what you do, the answer will be wrong. Okay. Now, arrangements. All right. Number of ways of arranging R objects out of N objects. All right. Or N distinct objects is NPR.
So permutations.
Yes, permutations. All right. And Gautam, what is NPR? The formula?
Sir, n factorial divided by n minus r factorial.
Absolutely right. Shabya, write it down. This is the formula for this. And you also don't know about factorial, I guess.
Sir, I know about factorial.
All right then. Okay, so this formula is used for this. If we have n different objects, all right, and you have to arrange r objects out of them, then the simple formula is NPR. All right, note it down, then we'll solve question.
Yes, sir. Done, sir.
Okay. Write down a question. In a train, 3 seats are vacant. In how many ways can 5 passengers sit? See the first method we have been solving till now. 3 seats. This can be filled in 5 ways. This in 4. This in 3. This in 3. So total is 60 ways. How to use
Yes,
the
sir.
formula? 5 passengers. P has to be seated. So 5P3. Using the formula, if you calculate 5 factorial upon 5 minus 3 factorial, the answer will be same. Is it clear?
Yes, sir.
Okay. Next question. How many 3-digit numbers can be formed with only odd digits? Let's try to solve this. Yes, 5p3. Right. Odd numbers is 1, 3, 5, 7, and 9. You have to make 3-digit numbers. First method would be 3 spaces. This can be filled in 5 ways, 4 ways, 3 ways. Right. Or you can use 5p3. All right. Now guys, this is without repetition. Clear? Gautam, Ashma, Abdul? Next question. How many 4-letter words we created using the letters of the word? Algorithm. Yes, the answer is 9p4. Right. 9 letters in total, 4 spaces, 9, 8, 7, 6, or directly we can write 9p4. That is 9 factorial upon 9 minus 4 factorial. All right. And this is 9 factorial upon 5 factorial. Simplify this also. Don't just leave this. All right. Next part. Number of ways of arranging n objects out of n different objects. All right. In here, we are arranging r objects out of n different objects. And here we are calculating n objects out of n objects. And this is the answer is here r equals to n. That means the answer is npn. So n factorial upon sorry.
Nothing, sir.
Okay. So n factorial upon n minus n factorial. So n factorial upon 0 factorial. And Shravya, what is the answer of 0 factorial?
1.
1. So the answer is n factorial. All right. If you have to arrange n objects out of n different objects, that means 10 objects out of 10 different objects, the answer is 10 factorial. All right. 5 letters and 5-letter words, 5 spaces, 5, 4, 3, 2, 1, and this is 5 factorial. Very easy. Write down a question. Note it down first. All right. The question is, how many different words can be formed using all the letters of the word Delhi? Anyone has the answer? Shavya, Gautam, Asma, Abdul. 5 or 5 factorial? Five factorial, and the answer of 5 factorial is 120. All right. Gautam, is it clear?
Yes, sir.
Okay. Now, see, you might be getting bored of this type of questions. All right. But what can you do? When you build the foundations, things tend to get boring. But now, very interesting thing. Write down dictionary problems. All right. Dictionary problems. Write down a question. Words are created by rearranging letters of the word table and arranged alphabetically. Then what is the position of the word table? Did you guys note down the question? Okay. Everyone understood the question? What the question is saying? Shavya, can you explain what the question is saying?
Yes, so the word table is arranged alphabetically, and then we need to find the position.
Right. So we created a dictionary, right? Something sort of a dictionary where only the words of this letters are there. So, Shavya, can you tell me what will be the first word of the dictionary here?
A.
First word. All right. We need all the letters. Words created by arranging all the letters. All right. That means you cannot leave out any letter. The first letter is A, right? After that, B comes,
B.
then E comes. Yeah. So the first word here will be ABELT, right?
Yes,
The
sir.
words do not have to have meaning. Is it clear?
Yes, sir.
Okay. So how to solve this? See, we need 5-letter words, right? So first we know that in dictionary, all the words starting from A will come. Is it clear? All the words starting from A will come first, right? All the words from A. So let me fix A in the first box. Now 4 letters, 4 boxes, that means 4 factorial, right? So from A, starting from A, I have 4 factorial words. Is it clear? Gautam, Shabya, Ashma, Abdul. All right. Now words start from B because B is the second letter in here. 4 options because we fix B here. That means 4 factorial again. So there are 4 factorial words starting with B also. Now E again 4 factorial words. L again 4 factorial words. Now comes T, right? We need the word that starts with T. As soon as T comes, what will be the first letter after T? Be A because in
A.
dictionary. Absolutely right. And Shavya, next letter
B.
B. So we are not counting this word because this is what we want. We want TAB, right? Now the next would be
E.
E. Absolutely right. This will come and then will be L. So this is one word. And the next word would be TABLE.
Yes, sir.
So this is the word we want. So how many
Yes,
words
sir.
are left? This is 4 factorial plus 4 factorial plus like this. So 4 into 4 factorial plus 1, right? So this is 97. So table is the 98th word. Is it clear, everyone? Gautam, Shavya, Ashma, up
Yes,
there?
sir.
All right. Let's see. Let's solve the question. The same question, all the words are arranged by rearranging the letters of the word gulab. All right. You have to find the position. All right. I'll give you a few minutes. Try to solve this. Gautam, is it clear?
Yes, sir.
Okay. Then solve this question. I need all the answers. Shavya, try to think about the previous question. All right. Then try to solve this. Don't worry, you can do this. Everyone gets stuck in the first time, right? Just arrange the letters. First is A, then B, then G, then L, then U, right? So all the letters from A, all the letters from B, then G will come.
L.
After G, the first letter that will come is A, and we don't want the letter from A, right? So these three, no matter what the arrangement is, we will not be counting. After that, GB will come. We don't want that. GL will come, we don't want that. Then GU will come, this we want. That means GU, after that A will come, we don't want. GUB will come, we don't want. GUL will come, we want that. Then A comes, then B comes. This is our letter, this is our word. So just count this one out. Is it clear, Shabya?
Yes, sir.
Okay. Gautam, do you have the answer?
No, sir.
No, all right. See, everyone, does it feel difficult? Okay. So the words will start with A. We don't want that. So four of the letters can be arranged in any way. That means 4 factorial. Same with B, 4 factorial. Then G comes. Yes, we want that. Then A comes. We don't want that. So rest of the letters can be arranged in any way. We don't care. 3 factorial. Then B comes. We don't want that also. Rest of the letters can be arranged in any way. We don't care. 3 factorial. Then L comes. Same case. Then U comes. Yes, we want that. A comes. We don't want that. 2 letters can be arranged in any way. 2 factorial. B comes. Same story. 2 factorial. L comes. Yes, we want that. Then A comes and B comes. This is the word. So 4 factorial plus 4 factorial plus 3 factorial, 3 factorial, 3 factorial plus 2 factorial plus 2 factorial. Right? So this is 48 and 18 and this is 4. So 2 and 2, 20, 50, 70. So 71. Right? 71st is the word. Is it clear, everyone?
Yes, sir.
Okay. Shabya, Ashma?
Clear, sir.
All right. See, this is not difficult. It just needs a little bit focus, right? This question comes in, you know, more marks question, 4 marks. Not the question. Another thing, number of ways of arranging n objects out of n objects where p are alike of one kind, q are of one kind, and r are of one kind. All right, you will face some difficulty in understanding the language. All right, but in an example you will be very clear about this. All right, in the previous questions we are solving where there are n different objects, right? All the objects are different, but here suppose there is a word which is, let's take a name Gotham, right? Gotham. So if we have to find all the words from these letters, can you tell me the answer? All the words that can be formed using these letters. Gotham, what is the answer? Right, Shavya, 7 factorial. Gotham, can you answer?
So what is that? Q R of?
Q are of one kind and
Okay,
R
sir.
are of one kind. Yeah. All right. So this is very easy. 4 letters, 4 factorial, 5 letters, 5 factorial. Here, how many letters? 7 letters, 7 factorial, right? But this is not the case because see, we have two A's here, right? So suppose I write A G U T H M. This is one word. Now I change this A to here and this to here. Again, I'll be getting the same word, right? So these are not two different cases. But when I did 7 factorial, I counted this as different cases. So this is the problem arises when P are alike. That means some letters are of same type. So the formula for this is n factorial upon p factorial, q factorial, r factorial. Write down the formula, then I'll explain. All right. What this means is, see here we had 7 letters. So 7 factorial as Sabya mentioned, but because a was 2 times, so I'll divide by 2 factorial. Is it clear, Shabya?
Yes, sir.
Okay. Then tell me if I take Ashma, how many ways to arrange?
4 factorial divided by 2 factorial.
Absolute light, 4 factorial divided by 2 factorial. All right. Now one word is very favorite of the teachers of the NCERT CBSE, Mississippi. Something like this is the spelling, I guess. If you know the word, very good. Is it the spelling of Mississippi? Mississippi. All right. How many words can be formed by rearranging this word? Anyone have the answer?
1 minute, sir. Sir, is it 11 factorial divided by 4 factorial into 4 factorial into 2 factorial?
Let's see. So we have one M here, and I is 1, 2, 3, and 4. S is 2 and 2, 4. P is 2, 3, 8, 11. So 11 total number of letters upon I is 4 times. So 4 factorials. S is 4 times, 4 factorials. P is 2 times, 2 factorials. This is the answer. Absolutely right. Clear?
Yes, sir.
Okay. Ashma, Gautam, Abdul.
Yes, sir.
Okay. Let's solve another question of this type. You have Allahabad. All right.
Done, sir.
All right. So we have 4 A's, L is 2, H1, B1, D1, right? 7, 9 factorial. 9 factorial upon 4 factorial and 2 factorial. Gautam, you don't have to divide 1 factorial, right? 1 factorial is 1 only. Is it clear, everyone?
Yes, sir.
Okay, Ashma Abdul. So basics of arrangement is finished. In the next questions, we'll try to do some more interesting questions, right? So please revise, and Shabya, look at the previous lectures.
Yes, sir.
All right. And in the next class, there is Viva. All of you remember that. Conic sections.
Okay, sir.
Yeah. See you in the next class then. Take care.
Thank you, sir.
Yeah. Okay.